Thank you very much, Lisa, and thank you all for being here. I was going to say this evening, but I realize it's not necessarily evening for all of you. So as you just heard, I'm publishing a book. In fact, it's released today in the United Kingdom, in a couple of weeks in the United States, with the same title as my talk, The Hidden Spring, A Journey to the Source of Consciousness. Hopefully, when I've finished in an hour's time, what I'm going to present to you, you will understand why the book has this title. The book is, of course, about consciousness. And I'm quoting here what the physicist Paul Davies recently wrote about consciousness. But I could have found 100 scientists saying basically the same thing. Davies says, among life's many baffling properties, the phenomenon of consciousness leaps out as especially striking. Its origin is arguably the hardest problem facing science today, and the only one that remains almost impenetrable even after 2.5 millennia of deliberation. Consciousness is the #1 problem of science, of existence even. So our topic tonight is not a small one. It is widely regarded as the #1 problem of science today. So my book is about this problem, but this is a lecture. And of course, I can't begin to cover all the complexities that require a book-length treatment. So what I'm going to say tonight is a sort of extracting things down to their essence. I'm going to simplify. And I'm going to simplify by focusing on just one strand, although it is a sort of a red thread running through the book, one strand of the argument. And I'll state that argument up front. It is that we have made so little progress in terms of solving the problem that Paul Davies identifies here, because we've been looking in the wrong place. We've been looking for the explanation of how and why consciousness arises in the cerebral cortex, the long-standing assumed seat of consciousness. And I'm going to argue that we should be looking elsewhere. We should be looking in a far more primitive structure, the brain stem, in particular, the reticular activating system at the core of the brain stem. And not at these higher cognitive functions that are performed by the cortex and in particular by the human cortex, but rather at far more basic functions of the kind that are performed in the brainstem, specifically raw feelings. I'm going to argue that raw feelings are the fundamental form of consciousness in all sorts of ways, and that if we shift our attention from higher cognition to lower, as it were, feelings, the hard problem becomes less hard. In order to escape the risk of overly abstract ideas, I thought I would tell my story via a series of cases, some clinical case histories. I've lined up 6 for you, and I hope I get through all 6 of them because as I say, I have only an hour. So let's hope I get through them all. But at least it'll give you some flavor of the lived experience of patients with disorders of consciousness who have been so helpful to me over the years in terms of my efforts to unravel this problem. But let's start in the obvious place. I'm going to read you now the formulation of the hard problem by David Chalmers. In a paper in 1995, he coined that term, and this is what he wrote. It is undeniable that some organisms are subject of experience, but the question of how it is that these systems are subjects of experience is perplexing. Why is it that when our cognitive systems engage in visual and auditory information processing, we have visual or auditory experience? The quality of deep blue, the sensation of middle sea. How can we explain there is something it's like to remain a mental image or experience an emotion? It's widely agreed that experience arises from a physical basis, but we have no good explanation of how and why it so arises. Now, this is the way that Chalmers formulated the hard problem. But of course, this is not a new problem. As Davies said, it's something we've been pondering for millennia. But in particular, I've emphasized this phrase, something it is like, in order to make a link back to another philosopher, Tom Nagel, who wrote in 1974, an organism has conscious mental states if and only if there is something that it is like to be that organism, something it's like for the organism. And later in the paper, that same paper, he wrote, if we acknowledge that a physical theory of mind must account for the subjective character of experience, we must admit that no presently available conception gives us a clue about how this could be done. So my aim this evening in this brief talk is to give you a clue about how this could be done. I told you I'm going to, well, let me first of all, sorry, I see what I have on the screen here is I've wanted to state as succinctly as possible what this problem is that I'm addressing. And you can think as I go along whether or not I am answering this question. This is the hard problem. Why and how is there something it's like to be an organism, something it's like for the organism? Now, what I started to say is I told you I'm going to address this via a series of cases in order to not get too lost in abstractions. Here's our first case. This is the case. He is, in fact, my brother. This photograph was taken when he was 2.5 or just short of 3 years old. And I, as you can see, was a baby. We were born in a small village, and for all sorts of reasons, we were rather isolated. So we were best of friends, and we got on famously. One day, 4 and a bit years after this photograph was taken, my parents were yachting, and my brother climbed up onto the clubhouse roof while I was wading in the waters of the lake below, and he tripped and he fell 3 stories and landed on his head on the paving stones below, fractured his skull and sustained an intracerebral bleed. He was flown by helicopter to a hospital in Cape Town called Groote Schuur, to the neurosurgery department, where amazingly, but not entirely coincidentally, where I work today. That sort of hemorrhage is a life-threatening emergency. But fortunately, in my brother's case, the bleeding stopped, and the hemorrhage, the hematoma reabsorbed, and he survived. And a few weeks later, he was flown back home. He looked exactly the same as he had before, apart from the fact that he had to wear a helmet to protect his fractured skull. But despite the appearance being the same, he was not the same. As a person, he was utterly different. And you can imagine, to me as a 4.5-year-old, how uncanny this is Lee. He looks like Lee, but he isn't Lee. It was, of course, a terrible tragedy for him and for my family. For me personally, it was extremely disturbing, especially in the way that I've just described. I couldn't get my head around the fact that he was so changed. And so in this way, I was confronted, I think, a little earlier than most of us are, with this fact that we ourselves, our subjective beings, our personalities, our minds, are somehow also just a bodily organ. And if that organ is damaged, then we're changed. And by implication, what had happened to my brother could have happened to me, could have happened to any one of us. If our brains were damaged in the way that his was, the hematoma reabsorbed, but it leaves damage. And also there's these things called axonal shearing from the kind of injury that he had. If this were to happen to any one of us, we would not be ourselves. We would be somebody else. And by further implication, when our brains die, we literally disappear. So this is the gravity of the problem that we're talking about. It wasn't obviously at the age of 4, I didn't decide, okay, in order to solve this problem, I better become a neuroscientist. But I have no doubt that those early childhood experiences are what drove me to study neuroscience, and in particular to be interested in that branch of neuroscience that we call neuropsychology. In other words, how mental functions relate to brain functions. When I went to university, which was to study this, which was in the early 1980s, I was, however, quickly disabused of the idea that studying neuropsychology would provide the answers I was looking for as to how does it happen? This thing that Davies was talking about, that Chalmers was talking about, how does it happen? How can it possibly be that a physical organ is me? How am I produced by these physiological processes in these anatomical structures? But this is not what I was taught. What I was taught rather was how the cortex, and I emphasize here cortex, because in the 1980s, neuropsychology basically was the study of higher cortical functions. Neurologists study the brainstem functions, those have to do with the body. Neuropsychologists study cortical functions, they have to do with the mind. And I was taught how visual information is processed in this part of the cortex, and somatosensory processes here, and auditory processes there. But when I asked my lecturers, where does all of this information, where am I in the processing of all this information? Where's the subject that receives the visual and auditory and somatosensory and whatnot information? And I was kindly advised by my professors not to ask questions like that. Those are not proper scientific questions, and they're bad for your career. But I wasn't studying this because I was interested in building a career. I really needed to understand how this works. And so when I was taught, as I'm showing in the slide on the screen at the moment, how visual information processing occurs in the visual cortex, and how incredibly elaborate all these different component processes are, how we go from the initial image in V1 to these various processing streams, whereby in one of them, you recognize color and movement and faces, and in another, if you're a human being, you're able to recognize letters and words and read, all of these things, and how ultimately all of this visual information is encoded into the hippocampus, into long-term memory. All of these functional mechanisms were incredibly interesting. But the problem for me was, visual information processing of this kind can be done by your mobile phone. And in fact, what I have on the screen for you now is not that different from a circuit diagram, which describes the sorts of information processing that your mobile phone performs. Your mobile phone can recognize faces, as you might have noticed when you're taking a photograph, and the way that it sifts through the stored images. It classifies them. These are faces, these are places, etc. Exactly the same sort of thing as as I was being taught about how our brains work. But the sentient subject who receives this information, what it is like to see, was not a respectable question. It wasn't addressed at all. Around that time, I read this book by Oliver Sacks called A Leg to Stand On. It was before he became so famous with his book, The Man Who Mistook His Wife for a Hat. In this book, A Leg to Stand On, in 1984, he wrote, neuropsychology, like classical neurology, aims to be entirely objective, and its great power, its advances come from just this. But a living creature, and especially a human being, is first and last active, a subject, not an object. It's precisely the subject, the living I, which is being excluded. Neuropsychology is admirable, but it excludes the psyche. It excludes the experiencing, active, living I. So that sentence, neuropsychology is admirable, but it excludes the psyche, captured exactly my dismay and frustration with my field. Such was how things stood in the 1980s. And I think that this has a great deal to do with why David Chalmers formulated the hard problem in the way that he did. I'm now going to read you a further passage from his book in which he clarifies that this hard problem pivots on the question of function, on the function of visual experience, for example. Let me read it to you. The easy problems are easy precisely because they concern the explanation of cognitive abilities and functions. To explain a cognitive function, we need only specify a mechanism that can perform the function. The methods of cognitive science are well suited for this sort of explanation, and so are well suited to the easy problems of consciousness. By contrast, the hard problem is hard precisely because it is not a problem about the performance of functions. The problem persists even when the performance of all the relevant functions is explained. What makes the hard problem hard and almost unique is that it goes beyond problems about the performance of functions. To see this, note that even when we've explained the performance of all the cognitive and behavioral functions in the vicinity of experience, there may still remain a further unanswered question. Why is the performance of these functions accompanied by experience? A simple explanation of the functions leaves this question open. Why doesn't all this information processing go on in the dark, free of any inner feel? Just to make clear the gravity of the problem that Chalmers is identifying here, I want to tell you briefly about what another philosopher said on this point. This was Frank Jackson in his celebrated knowledge argument. The story revolves around a visual neuroscientist named Mary. And I'm going to tell the story in a simplified form in the interests of time. Mary knows everything that there is to know about the functional mechanisms of vision, but she's blind. So although she knows exactly how light waves are transduced by the photosensitive rods and cones of the retina and transmitted to the lateral geniculate body and from there to the visual cortex, and how all those processing streams that I showed you in the earlier slide further in specialized modules process that information, exactly what those neurons do, exactly what the functional mechanisms of the different processing streams are. Despite all of that, she knows nothing about what it is like to see. And then, thank God, one day, the gift of sight is bestowed upon her. And for the first time in her life, she actually experiences that deep blue that Chalmers spoke of, the actual quality of visual experience, redness, blueness, movement, form, contour, and so on. And Jackson's point is, at that moment, she learns something utterly new about vision, something which was not predicted, not explained at all by her understanding of the physical mechanisms whereby visual information is processed. And the point is that because those mechanisms can be absolutely understood without there being any, not only any need to understand what visual experience is like, but also no bridge. It doesn't predict that there will have to be visual experience. And so this new thing, this new qualitative, experiential thing that Mary becomes acquainted with is not at all contained within the knowledge. That's why it's called the knowledge argument, that she had of the functional mechanisms of vision. And the alarming conclusion that people like Jackson and Nagel and Chalmers come to in consequence is that conscious experience, the actual something it is likeness of seeing, exists in some sort of parallel universe, some other dimension, some place other than the physical universe in which causal mechanisms explain how one thing produces another. So this is what Chalmers is talking about when he says, why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner field? The information processing accounts, the mechanistic functionalist accounts of visual processing in the cortex. And I'm using vision as my model example because that's what we do in cognitive neuroscience when it comes to trying to understand the mechanisms of consciousness. That's where we've been looking on the assumption that if we can isolate the mechanism of visual consciousness, then we can generalize from there to other forms of consciousness and explain consciousness as a whole. Chalmers's point is that Mary, who knew everything there was to know about the functional mechanisms of visual information processing, knew nothing at all about what it is like to see. This seems to be an entirely different order of things. So how are we to make sense of this? By the 1990s, John Killstrom was able to write an article with this title. It's a review of the literature on unconscious visual and other perceptual and other cognitive cortical mechanisms. The title says it all: perception without awareness of what is perceived, learning without awareness of what is learned. The literature, the research literature reviewed in this paper shows in a nutshell that you can perceive visually and in other ways. You can process this sort of information without knowing that you're doing so. You don't seem to have to know that you're doing so. The cortex and the brain as a whole can process visual and other perceptual stimuli and act upon those stimuli without any awareness that they've done so. The same applies to learning. You can learn things and remember things, and they will influence what you do in the future without having any knowledge that you've learned those things and that you're remembering things. All of this can go on automatically, to paraphrase Chalmers, in the dark. Just to give you some sense of the kinds of evidence that Killstrom drew upon in writing this review article and coming to the conclusions which are sort of alluded to in the title. In one study, research participants are shown via a paradigm called, an instrument called a tachistoscope, which flashes visual information so briefly for so few milliseconds that you don't even know you've seen anything at all, let alone what you've seen. In this experiment, the participants were shown two faces: face A, under which was written the word rapist, and face B, under which was written the word philanthropist. Now remember, they didn't know they'd seen anything at all, let alone that they'd seen a face and read a word. After the tachistoscopic phase of the experiment, they're then shown supraliminally those same two photographs and asked which of the two faces they prefer, which of the two people they prefer. And with a very high degree of statistical significance, the research participants choose face B. When asked, why are you choosing this face over the other? They say, I don't know, because of course they don't know consciously why they're doing so. They say it's just intuition, or my gut feeling. I just prefer this chap. We know why they did it. They did it because of the words that were associated with those faces. And that's precisely the point, that this kind of cognitive process, this higher visual cortical, because let me be clear that recognizing faces is a uniquely cortical function. And indeed, reading with comprehension is a uniquely human cortical function. So these sorts of functions can go on perfectly well without awareness. And this is the essence, in a manner of speaking, of what Chalmers is saying. He's saying, you know, these things can go on in the dark. And that begs the question that Chalmers asks, why doesn't it do so? Why do we have to be aware of these things at all? And the provisional conclusion that I now want to state is that it's because they don't. Visual cortical processes and all cortical processes and cognitive processes are not intrinsically conscious, as Killstrom's review shows. Therefore, it's no surprise that if we have focused our research efforts on trying to understand the brain basis of consciousness, the physical mechanisms of consciousness, by looking at functions which are not inherently intrinsically conscious, which can work just as well without consciousness, then we're looking in the wrong place. If you remember my introductory remarks, this is the red thread that's going to run through what I'm going to say to you tonight. So let's move on to my next case. I told you that when I was a student and I was taught about how these different streams of information coming from our sensory organs and projected onto our cortex produce visual consciousness, auditory consciousness, etc. And I asked my professors, but where am I? You know, where is the subject who receives all this information? By the 1990s, 10 years after I asked that silly question, which was considered silly, it's a naive question, but many of the most naive questions are the most important questions. By the 1990s, neuropsychology was asking those questions itself. And the answers that it came to was that, you know, visual and auditory and somatosensory information, the sort of raw phenomenal consciousness, is not the main thing about subjectivity. It's where it all comes together, that question that I'd asked, where does it all come together? And one of the main answers was it all comes together here, in the prefrontal lobes. So, for example, Bernard Baars and Stanislav Kahan were saying that there's a global workspace, a sort of integrating of all of these different information streams here. And this is where the subject of the mind is. Remember, consciousness, the global workspace in the sense of not just information processing streams coming from our sensory end organs, but rather the subject of the mind that receives them. So I'm going to, remember, I'm just giving you an impressionistic account in this brief lecture. I'm going to ask you, as scientists or people who understand science, if there's a theoretical claim that this part of the brain is where consciousness is generated in the sense of a subjective sentient being of the mind, then if this part of the brain is damaged, then that function should be lost. So somebody who has no prefrontal cortex should have no subjectivity in the sense that we are talking about here. No person who receives all this information and knows this is my vision. I am a sentient being, the sort of agent or I, the active me that Oliver Sacks was talking about. Damage to this part of the brain, complete damage to this part of the brain should completely remove the thing that we're looking for. So I will now briefly describe to you a patient of mine who I'm calling patient W, who due to a complex pathology, basically a subarachnoid hemorrhage in the anterior communicating artery, which needed to be operated on, and the operation didn't go that well. And then there was sepsis, and then it wasn't recognized early enough, etc., etc. Basically, after a series of operations, he ended up like this, with absolutely no prefrontal lobes. So there's the prefrontal lobes. He doesn't have any. Here you see it again. But fortunately, he has a little sliver of cortex here, language cortex, which enables him to describe his experience. So I explained to patient W that according to my colleagues, he should lack a self. He should lack this overarching sense of sentient being, receiving this perceptual information and knowing it's me who's seeing these things, that me should be missing. I asked him, is that missing? He said, no, not at all. So I said, well, then bear with me. I'm going to ask you a series of questions whereby I can illustrate, demonstrate to my colleagues that they're wrong. I said to him, are you consciously aware of your thoughts? He said, yes, of course I am. I said, in order to confirm that, I'm going to ask you to solve a problem that will require you to consciously picture a situation in your mind. He says, okay. I say, imagine that you have 2 dogs and 1 chicken. He says, okay. I say, do you see them in your mind's eye? He says, yes. So I say, now tell me, how many legs do you see in total? You get the point that if he's there looking at this visual information that he's conjured up in his mind's eye, he should be able to count 2 dogs, 4 plus 4, 1 chicken, 2, totals 10. And that would show that there's somebody there looking at the visual information. So you can imagine my disappointment when I say to him, now tell me, how many legs do you see in total? And he said 8. And I said, 8? And then he said, yes, the dogs ate the chicken. Now, that's not the best joke in the world, but it shows that there's somebody at home. There's Mr. W was there thinking, looking at this information and even been able to take this additional humorous step of imagining that the dogs had ate the chicken. So the idea that as the sentient being of the mind resides in the prefrontal cortex, I don't believe it. And of course, it's not based only on this case. I'm using that to illustrate a point. The other major theory in cognitive neuroscience as to where the subject of the mind exists in the cortex is associated with the name of Bud Craig. And he identifies the insula as the critical part of the cortex. The insula is not like the prefrontal cortex where all the different information processing streams converge from your various senses, leading to your capacity to make decisions about what are you going to do about it. But rather it's where the visceral internal information from the vegetative body is transmitted to the cortex and integrated with this exteroceptive information. It's a very, very mainstream theory that this is where the self resides in the cortex. So let's see what happens if this part of the cortex is damaged, as it was in this patient, patient B, a patient of Damasio's. Like I did with my patient W, Damasio interviews his patient and asks him if he has a self, because the prediction arising from Craig's theory is that he should lack such a thing. Damasio says, do you have, this is a dialogue, a conversation which hasn't been published, but an article on this case has been published. Do you have a sense of self? Says Damasio. Patient says, yes, I do. What if I told you that you weren't here right now? Patient says, I'd say you've gone blind and deaf. Damasio says, do you think that other people can control your thoughts? He says, no. So, and why do you think that's not possible? He says, you control your own mind, hopefully. Damasio says, what if I were to tell you that your mind was the mind of somebody else? Patient says, when was the transplant? I mean, the brain transplant. Damasio, what if I were to tell you that I know you better than you know yourself? Patient says, I would think you're wrong. Damasio says, what if I were to tell you that you're aware that I'm aware? He says, I would say you're right. Damasio, you're aware that I'm aware? Patient, I'm aware that you're aware that I'm aware. Please note all these references to I. This is the very thing that's supposed to be missing in such patients. So clearly the sentient being of the mind is neither in the prefrontal cortex nor in the insular cortex. But these patients have some cortex left. What about a patient who has absolutely no cortex? What if the cortex as a whole were to be removed? Surely this would remove the sentient subjectivity that we are seeking to explain with our cortical theory of consciousness. Well, here's a patient, 3 years old, this one, with absolutely no cortex. This is a condition called hydranencephaly, where the patient is born with a brainstem and a cerebellum, which hangs off the back of the brainstem, but no forebrain at all. Is she conscious? Yes, she is. Here she is. She's awake. She goes to sleep at night. She wakes up in the morning. Clearly, she's conscious. But much more importantly, look at this. This is her reaction to her baby brother being placed on her lap. She responds emotionally to this experience. So it's not only that she's awake, it's not some sort of blank wakefulness, but a reactive mind with feelings and content. It cannot possibly be representational cognition of the kind that the cortex performs, because she doesn't have any cortex. She has only a brainstem, and yet she's conscious, and her consciousness has a particular quality, and it doesn't have anything to do with what's streaming in from the outside consciously, because remember, the brainstem only processes sensory information unconsciously. This has got to do with her subjective response to that information, even though she has no cognitive clue what that information is actually about. It's a pure, raw feeling. And it's not just her. Most of these kids are like that. Here's another patient. Tell me this patient isn't conscious and that there's nobody home. Bjorn Merker wrote a review article about these patients, who he studied a great many of them. And I'm not going to read you this long quotation, but you can see the words that I've emphasized in yellow. They have a wide range of emotions, and most importantly of all, those emotional responses are situationally appropriate. In other words, the patient shows laughter or irritability or fear in response to stimuli which would evoke those same sort of feelings in you and me. So this is a weighty piece of evidence that the cortical theory is wrong. The parts of the cortex that are supposed to be the centers for consciousness, the integrative centers where a sentient self comes about, even just the little smatterings of evidence that I've given you this evening show that this is not the case. And even in patients in whom there is absolutely no cortex, there's evidence that there is consciousness not of the cognitive kind that we've been focusing on in our attempts to solve the hard problem, but rather consciousness of a far more rudimentary kind, basic, raw feelings of the type that you saw these two little girls and other children like them with the same condition able to express. But of course, how do we know? What it's like to be such a? Is there anything it's like to be such a child? These are just behaviors. We can't be sure what they're experiencing. But let's just slow down. Although I'm anxious about the time, I keep on looking to my left, which is where my clock is, and I see that I must speed up. But let's just make sure that I'm conveying this really essential point. You can remove the cortex, the supposed seat of consciousness, in its entirety. And I say remove, of course, in these children, it's not removed experimentally. In experimental animals, it is removed. And we find exactly the same thing. They are conscious, they're awake, and they display a full range of emotional and situationally appropriate emotional responses. By contrast with that lesion evidence, now we look at the brain stem. If there's damage in these structures, these tiny structures in the primitive brain stem called the reticular activating system, then the lights go out. So the lights do not go out if there's no cortex, but if there's tiny lesions in the reticular activating system of the brainstem, as small as 2 cubic millimeters. Fisher and colleagues recently published an article in which they studied numerous patients with brainstem strokes and showed that a 2 cubic millimeter lesion in the parabrachial region is all that's required to totally obliterate consciousness. So what that shows is that cortical consciousness is dependent upon brainstem consciousness. What's generated here in the reticular activating system is a prerequisite for cortical consciousness. And what is more, remember that cortical consciousness is not always present. In other words, the cortex is able to process information without consciousness. So what makes it conscious is activation by this reticular activating system. Now, that's not controversial, what I've just said to you. I'm making the argument we're looking in the wrong place. This is not intrinsically conscious. This is the foundation of consciousness. Why don't we look there? And I've showed you in those hydranencephalic girls that the people who only have a brainstem have consciousness of a particular type, and that is affective consciousness. So is this not this intrinsic prerequisite for all of the other forms of consciousness? Is this not the place that we should be looking if we're trying to find out what the functional mechanism of consciousness is? So let me now go to my case 5. And the reason I'm doing this is because I'm very much aware that in the case of these kids with no cortex, you can't be sure that they have consciousness because they can't speak. The one function which certainly is cortical is language. And my patient W was able to describe his mental states because he had this sliver of frontal cortex, which enables us to produce language. Those children didn't. So we don't know. They can't tell us what they're experiencing, just like our pet dogs and cats can't tell us what they're experiencing. We sense that they're conscious. They respond emotionally. We have relationships with them, but we can't know for sure. So in science, in such a situation, what we have to do is rely upon multiple lines of converging evidence. We have to make predictions on the hypothesis that the brainstem produces consciousness. On the lesion studies suggest that that's where the consciousness comes from. And I'm saying it is a consciousness of a particular type. It's feeling, it's affective consciousness. Then using another method, for example, deep brain stimulation, if we stimulate those structures, those deep brainstem structures in patients who do have intact cortex and can tell us what they experience, we might predict that they would experience intense affects. And that's exactly what happens. If you stimulate the substantia nigra, which is a midbrain part of the reticular activating system, this is what happens. In a patient, who's 65-year-old patient with Parkinson's disease, that's why the stimulator was put into her brain. But a patient who'd never had any psychiatric pathology in her life, within 5 seconds of the stimulator being switched on, it had actually gone deeper than the intended site. The intended site was not in the brainstem. It went a few millimeters too deep into the reticular activating nucleus that I mentioned. And within 5 seconds, she falls into a depression. I'm falling down in my head. I no longer wish to live, to see anything, hear anything, feel anything. When asked if she's in pain, she says, no, I'm fed up with life. I've had enough. I don't want to live anymore. I'm disgusted with life. Everything is useless, always feeling worthless. I'm scared in this world. Please note this, I don't want to live anymore, a suicidal depression. When asked why she's so sad, she says, I'm tired. I want to hide in a corner. I'm crying over myself, of course. I'm hopeless. Why am I bothering you? After the stimulation, within 90 seconds, the depression disappears. The patient very bravely or generously agreed to do a double-blind trial after that, where Blomstedt stimulated either in the higher structure that he had aimed for or in the reticulate structure that he had struck accidentally, without the patient knowing where he was stimulating. And every time that he stimulated in the reticulate nucleus, she fell into this deep despair. So this is a second line of evidence. You can actually stimulate intense emotions by stimulating those deep brainstem structures. Here's a third line of evidence, functional imaging, PET imaging in this case. These are normal subjects with intense emotional states. They are feeling intensely sad, angry, happy, or fearful. The PET imaging shows where in the brain the activity is that's generating this mental state. And in all of these cases, it's in the brain stem. Sadness, anger, happiness, fear. Look at what's going on in the cortex. Next to nothing. So it's absolutely clear by this method too that the affects are generated in the brain stem. One last line of evidence is psychopharmacology. Psychiatrists tinker with the neuromodulatory chemicals that are sourced in these very same brainstem nuclei. So antidepressants increase serotonin, which is sourced in the RAFE nuclei of the reticular activating system. Antipsychotics block dopamine, which is sourced in the ventral tegmental area of the reticular activating system. Some anti-anxiety drugs block noradrenaline, which is sourced in the locus ceruleus complex of the reticular activating system. If all that this system did was woke you up or sort of produced a sort of background level of consciousness, which is the standard view of what this part of the brain is doing, this is why when you lesion it, you go into a coma, then anesthetists might be interested in these brain structures and these brain chemicals. But no, psychiatrists are. Psychiatrists, doctors for feelings, treating emotional disorders. Clearly these neuromodulators sourced in the reticular activating system have something fundamental to do with feeling. So let me just sum up. I'm going to tell you about another one of these neuromodulators in a few minutes if I get that far. But let me just sum up what I'm saying. I'm saying that the evidence is very strong that the source of consciousness, remember the subtitle of my book, is this hidden spring deep in the reticular brainstem, are structures which are prerequisite for consciousness to occur. Think of the forebrain or the cortex as a sort of a television set, and think of this as the power supply. The standard view is, well, of course, consciousness happens in the cortex. Like televisual program transmission happens in the television set. It has to have a power supply. It has to be plugged in at the wall, but that doesn't mean that the source of television is the power supply. But as you've just seen, if you tinker with this power supply, you change the program. You change the actual televisual content. It's not just a power supply. It is literally the font of consciousness. And because it's prerequisite for these cortical forms of consciousness, the cortex isn't conscious unless it's aroused by the brain stem. And because, as I've showed you, the brain stem is generating not some power supply, but rather consciousness with a particular content and quality, a particular feel, a particular something that it is likeness. That means the foundational, elemental, basic form of consciousness is feeling. And feeling is prerequisite for all other forms of consciousness. Sigmund Freud, the discoverer of the unconscious, even Freud, who was the person who taught us that the bulk of our cognition is unconscious. What we rediscovered 100 years later in cognitive science, that the bulk of our cognition is unconscious. Even he said, it's surely of the essence of an emotion that we should be aware of it, that it should become known to consciousness. Thus, the possibility of the attribute of unconsciousness would be completely excluded as far as emotions, feelings, and affects are concerned. Now, I've emphasized the word feelings because the words affect and emotion mean different things to different people. Some people claim you can have unconscious emotions. They don't agree with Freud. So I want to be clear that I'm talking about this thing, feeling. You cannot have a feeling that you do not feel. And this is not just a linguistic point. As I've just showed you, the brainstem mechanisms that generate raw feeling, they generate consciousness itself. But I say again, this thing that I'm calling feeling cannot be other than felt. If you don't feel it, it isn't a feeling. And what I'm saying, therefore, is that unlike cortex, the processes of which, the information processing of which is not intrinsically conscious, shouldn't we be looking to the brain stem, the processes of which are intrinsically conscious, in fact, are the source of all consciousness? If we want to understand the function of consciousness, then surely we need to understand the function of feeling. David Chalmers, one more time, he says, this is not to say that experience has no function, perhaps it'll turn out to play an important cognitive role, etc. And he ends up saying, there's no cognitive function such that we can say in advance that explanation of that function will automatically explain experience. This is, you can see, a reiteration of what I said to you earlier. But please note, it's the word cognitive. If you change the word cognitive to affective, would he ever even have said this? There is no affective function such that we can say in advance that explanation of that function will automatically explain experience. I'm saying in advance that an explanation of the function of feeling will automatically explain why it feels like something, because that is the function of feeling. I hope you can see why this is an important red thread in the argument of my book. If we're wanting to understand consciousness, we should be focusing on its most basic form, the form which is intrinsically conscious, that is to say feeling, because feeling has to be felt. Unlike vision, unlike hearing, unlike memory, unlike all forms of cognition, for the most part, they're unconscious, but feelings are always conscious, and they are prerequisite for the higher forms of consciousness. So if we understand the function of feeling, then we understand the function of consciousness. That's where we should be looking. I say again, there is every possibility that if you can explain the function of feeling, then you'll know why you feel it. So what is the function of feeling? Well, it's an extended form of homeostasis. Homeostasis, as many of you might know, is the basic mechanism that keeps us alive. Living organisms, unlike inorganic matter, don't dissipate. They don't just, if the ambient temperature is 10 degrees, then we just sort of become 10 degrees ourselves. If we did, we would die. So we can't dissipate, we can't equalize with our environments, we can't allow ourselves to obey the second law of thermodynamics, which states that in any natural process, entropy will always increase. Homeostasis resists entropy. We say, no, I can't equalize. I have to maintain a particular temperature range. I have to stay between 36.5 and 37.5 degrees Celsius. And if I deviate from that, it's a problem. It's a demand for work. And I have to perform work to get myself back into the temperature range that is viable for life. And I speak here of temperature range. This applies across a wide range of physiological parameters. So you have, blood glucose levels, blood oxygen levels, hydration levels, sodium levels, etc., that you have to remain within, otherwise you die. And you note the word prediction here. There are algorithms built into our brains which say, if you're getting too hot, that's a problem. So you've got to do something. And what must you do? The algorithm says, well, sweat, that'll cool you down. Pant, that'll cool you down. That's the work that you have to do to get yourself back into your viable range. So that's how homeostasis works. And I said, feeling is an extended form of homeostasis. And that extended form is that when you deviate from your expected states, from your viable states, it feels bad. The value system that underpins all life is that it is bad to die and good to survive. So if you're moving in the direction of death, of a physiological state which is incompatible with life, it feels bad. That is the function of unpleasure. That is the meaning of unpleasant feelings. It means this is bad for me. And conversely, performing the work that gets you back into your viable state feels pleasurable. And this is how you know that you're heading in the right direction. Why is this important? I told you that you have to have predictions here, algorithms built into the system that tell the system what to do. Demand for work, I know what I got to do, got to pant, got to perspire. That's the work, gets me back to my required temperature range. But the enormous adaptive advantage provided by feeling is that if you are in a situation for which you do not have a predetermined prediction, for which there is not a phenotypic algorithm built into your brain, then the feeling tells you here and now whether you're heading in the right direction or wrong. Let me give you an example. You're in a respiratory control is an automatic process. You don't need to be aware of your need for oxygen in order to breathe. It just happens automatically. But if you're in a building that's on fire and carbon dioxide is filling the air, then suddenly respiratory control becomes conscious and you feel this demand for work in the form of an acutely unpleasant state of mind called air hunger or suffocation alarm. Now you're in a situation you've never been in before. You can't possibly predict. You've never been in a burning building, let alone this particular one. And you can't possibly predict what to do. So that's a state of uncertainty with no predetermined predictions. And the way in which you solve that problem is to feel your way through it. So if I go this way and my air hunger gets worse, that's bad. It feels bad. That means it's bad. If I go the other way and my air hunger reduces, that's good. That means I must go that way. So the oxygenation in the air is felt without there being any preordained solution to this particular problem. You feel your way through it. So feeling tells you how you're doing within this basic biological frame of values, scale of values, which is that it's good to survive and bad to die. And you feel what is increasing and decreasing your chances, your probabilistic chances of surviving by feeling the feelings. So that enables you to make choices. And this too, I cannot emphasize enough. Choices have to be grounded in a value system. Something has to be better and something has to be worse. Otherwise, you have no basis for making a choice. And feelings provide the value system which enables choice in unpredicted, novel situations. So you decide which way to go on the basis of what feels good and what feels bad without any cognitive knowledge as to what that drives the cognition. And you feel your way into your cognition so that what you're perceiving and what you're thinking, flavored, colored, driven by the feeling, determines which choices you make. That is the function of feeling. That is what feeling adds to basic automatized homeostasis. Now, I've just identified one of the two most essential properties of affect, that is valence. It feels good or it feels bad. But I must add that it also has a categorical quality. Each affect feels, so air hunger feels different from sleepiness, feels different from the need to urinate, feels different from fear, feels different from separation distress, feels different from thirst. Each of these has a flavor, a categorical quality of their own, because you need to know what need is being met or not being met. So the color coding or flavoring, the qualification of these different affective needs is why consciousness has quality. So consciousness in its basic form is inherently valuative and it's inherently qualitative. And it does something. What does it do? It enables you to survive in unpredicted situations, which is an enormous adaptive advantage over creatures who do not have this capacity. So we're coming, I notice I really have to end earlier than I would have liked, but we're coming to the crux of the matter, which is that this is the function of feeling. So remember the question I was asking, why and how is there something it's like to be an organism, something it's like for an organism? Well, affect, feeling, explains why it's something, why it has to feel like something. The feeling, the quality of it and the category of it is its very essence. It's what it does is to bring to the awareness of the organism, for the organism, how it's doing in terms of its literal potential to exist, to continue existing. Its most basic design principle, the design principle that homeostasis embodies. And this extended form of homeostasis, bringing to the level of awareness by the organism of its state as it's navigating uncertain environments, is the function of consciousness in its most basic form. And going back to Chalmers's claim that if you explain the function, it doesn't explain why it feels like something. I'm saying that doesn't apply in the case of affect. And affect is generated in the brainstem, which is the source of all consciousness. All consciousness is contingent or dependent upon brainstem consciousness. Now, I'm going to end here so that there's time for questions. I just want to let you know that in my book, I then go on, based on work I did with Carl Friston, to explain how that mechanism works mechanistically. Homeostasis is not complicated. It can be reduced to laws. And if affect, feeling, is an extended form of homeostasis, it too can be reduced to laws. These laws are explicated in the book. And it explains how feeling governs, how voluntary action and learning from experience works in the brain. I was going to tell you this one last case, but I don't have time. So I'll just flick through and tell you, read my book, please. This is a complicated topic. I can't begin to do it justice in a short talk like this. So why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner feel? I hope you can see why I believe that when it comes to feelings, they can't go on in the dark. They can't go on without any inner feel. Their very function, their very causal contribution within the physical economy, bodily economy of the living organism is to feel. And the feeling is what has the functional causal consequences that Chalmers felt was so badly missing when it comes to perception and cognition, although he didn't realize that his argument applied only to perception and cognition. I am sorry I've had to rush at the end, and I want to remind you for that reason that I said at the beginning only that I was going to give you a clue. Please read my book, The Hidden Spring, out today in Britain and in a couple of weeks in America. Thank you very much. I look forward to your questions.